Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you all for coming this evening. My name is Duncan Watts. I'm a principal researcher here and one of the 13 founding members of the Microsoft Research New York lab. I'm standing in tonight for Dave Pennick, our assistant lab manager, who was supposed to deliver these remarks. Unfortunately, Dave's father passed away on Tuesday morning, so he's obviously not able to be with us, but our thoughts are definitely with him and his family. As you know, tonight is the first instance of what we hope will become a vibrant seminar series bringing together the premier data science research institutions in New York, the Columbia Data Science Institute, Cornell Tech, NYU Data Science and CUSP, and of course our own lab, MSR New York. As you're also aware, despite the numerous common interests that we in the New York data science research community share, opportunities to interact across institutional boundaries are regrettably infrequent. And as a result, we have a tendency to remain in our own silos, potentially missing out on valuable conversations and even collaborations with our peers in other locations. The primary purpose of this seminar series is to help break down these barriers by bringing all of us together on a semi-regular basis to learn about each other's work and also get to know each other socially. Correspondingly, the structure of these evenings will be deliberately informal. The intent is to start the evening off with a short 30 to 45 minute technical talk and then devote the bulk of the evening to mingling over wine and cheese outside there. To begin with, the series will be held here at MSR New York, if only so we can give our lovely but somewhat underutilized public space a proper workout. But over time, we hope that the location will migrate to venues at Columbia, Cornell, and NYU. Given that this is the first event, and that we are all still getting to know one another, the technical component will be a little bit different. Rather than a single speaker, we will have, in addition to my remarks, brief overviews of the other three participating institutions. Maura Neyman will speak about Cornell Tech, Tony Jabara will speak about Columbia Data Science, and Jan LeCun will speak about NYU Data Science. Following these remarks, Jennifer Chase, the director of the MSR New York and also MSR New England labs, will then moderate a short panel session on the general topic of the evolving New York data science community. Before I hand over the lectern to Maura, Tony, and Jan, let me say a few quick words about MSR New York. It has now been almost 2 years since 13 of us founded this lab under Jennifer's leadership. In fact, we are hosting our 2-year anniversary celebration on May 5th. And although in some respects that time seems to have flown by, it is also amazing how much has happened in that period, both in MSR and also in New York City. From the lab's perspective, it was a pretty chaotic start to begin, to be honest with you, in part because of the turmoil at Yahoo that we left behind, in part because we were all trying to learn how to be a part of a new organization at the same time, and in part because we had no physical home of our own. 2 years later, I think it's safe to say that we all feel very much at home, both in our new and quite beautiful physical space and also at Microsoft. And we're making exciting progress on several important fronts. Aside from our founding team, we have added several new members, some from other MSR labs and others recruited from prominent universities, enhancing both our diversity and also our quality. We have a vibrant visitors program comprising both short and long-term visitors who inject continual variety and outside perspectives into our routines and discussions. We have a large and active intern program that allows us to supervise and collaborate with outstanding graduate students from the top universities across the country and indeed the world. We have continued to generate world-class research in machine learning, computational social science, and algorithmic economics, including most recently accounting for 8 out of the 80 accepted papers to this year's ACM conference on economics and computation. We have also begun to have an impact internally at Microsoft, with our researchers actively reaching out to product teams across the company and initiating increasingly ambitious projects. We'll be talking a lot more about these accomplishments on May 5th, and I hope that some of you can join us again then. But given tonight's purpose, I'd like to emphasize that the past 2 years have also witnessed a series of exciting developments across the broader New York data science the broader New York data science scene. Cornell Tech, for example, which was announced only months before our founding, is now up and running in temporary space just a couple of blocks west of here in the Google building, and construction on their eventual Roosevelt Island campus is, I believe, imminent. Almost contemporaneous with our founding, NYU announced the launch of CUSP, the Center for Urban Science and Progress, and just months later, Columbia announced the creation of its Institute for Data Sciences and Engineering. I'm pleased to welcome Steve Koonin here tonight and Kathy McCohen, who are leading both those institutions. Shortly after that, NYU separately announced its own Center for Data Science, and then in 2013, along with UC Berkeley and University of Washington, launched a 5-year initiative in data science funded by the Moore and Sloan Foundations. And finally, over this same period, the tech startup scene in New York has really exploded, with companies like BuzzFeed, Etsy, Foursquare, and hundreds of others gaining increasing prominence, and even beginning to shift the economic center of gravity in New York away from its historical location in finance. Looking back on all these developments, it now seems almost prescient that 2 years ago, Microsoft decided to open a data science-oriented lab in New York. Maybe it was just lucky. But regardless of whether or not we anticipated it, now is an extremely exciting time to be in this particular community, in this particular city. I hope this seminar series will help the different centers of excellence for data science interact and learn from each other, and in so doing, help New York to become a world center of excellence for research and technology. Before closing, I would like to say a couple more things. First, I want to thank the Data Science Seminar Organizing Committee, led by our own Jaren Budak, and joined by Moore Neyman, representing Cornell Tech, Chris Wiggins, representing Columbia, and Jan LeCun, representing NYU, for organizing the program this evening, and Jeff Chirico, Irene Money, Ari DeLuna, and Ann Jensen for providing the technical, catering, and logistical support. And finally, on behalf of the entire MSR New York lab, I would like to publicly congratulate our boss, Jennifer Chase, on her recent election to the American Academy of Arts and Sciences. My only surprise at this announcement is that she wasn't a member already, but she assures me that she's happy to be a member of the class of 2014 on the grounds that she is now classmates with Al Pacino. Congratulations, Jennifer.
So I wasn't sure what to expect, really, because I was asked to give a technical talk, and then I was told it was 5 minutes. And then I just realized that I should really talk about the Center for Data Science at NYU. So I have sort of a boring talk about the CDS, but we can talk about this at the after in front of drinks. I think it would be more useful. In the meantime, I have a demo that runs just about 5 minutes, so I'm going to do that. All right. So let's see. All right, so I got, you're not seeing anything on the screen yet, but you will in just a second. This is just to show you a bunch of stuff that are going on in my lab at NYU in collaboration with Rob Fergus, as well as you know, I'm wearing a second hat, which I'm actually hiding behind my back right now. The second hat being Director of AI Research at Facebook. And one of the things that we've been working on over the last couple of years for some of you, 10 years for some of us at NYU, and I'm sorry to say 25 years for me, is deep learning. And deep learning in the last year or two, I'm sure many of you are aware of what this is, have become extremely successful. And another thing I'm sorry to say is that there's a lot of cycles that are being burned to run deep learning algorithms these days by Microsoft, Facebook, Google, and it's gonna get a lot worse over the next few years, to the point of we're going to be boiling the oceans or consuming a few nuclear power plants just to run convolutional net. So here is a convolutional net. This one runs on a laptop, and it can recognize stuff that I point the camera at. So let's see if it recognizes this notebook computer. That's a notebook computer. So each recognition here takes about 5 billion multiply adds to do this recognition. Let's see if it works on microphone. Unidentified object, water bottle. Yeah, it doesn't like this kind of microphone, does it? How about this guy? And not so great either. All All right, how about this? What is this? That's a loop. Yeah, close enough. How about that? Digital clock. Yeah, okay. Digital clock, digital watch. That's good enough. I'm going to use your shoes, okay? Don't move. Loafer.
Ouch.
Folding chair. Okay, close enough. Laptop? No, that's not a laptop. It's a folding chair. I don't think it knows about stools, but dining table. Okay, portable. Yeah, close enough. Yeah. So, okay, now we haven't totally solved vision yet, but we're getting pretty close. Remote control. So this thing knows about the 1,000 so-called ImageNet category, and I lost my cell phone. Does anyone have a cell phone? How about this? Odometer? Well, close enough. Yeah, it would be a monitor. So you get an idea of what, I'm not sure if it knows about this at all. Lamp. Spotlight. Okay, spotlight, not bad. So, you know, we haven't, it's not like vision is completely solved, but it's getting pretty close. And things are getting better and better by the day as our machines become more powerful and as our data sets become bigger and bigger, and companies like Microsoft, Google, and Facebook are furiously collecting data to improve the performance of the system, and boiling the oceans doing it. So here's another version of this demo, which this one I can train to recognize any object I pointed to. So let's say I pointed to Duncan here. So Duncan, you're going to be A, okay? So I click on the learn button a couple times, and now it recognizes Duncan. And if I point it someplace else, it's not Duncan. And you look like Duncan.
Thank you. You're recovering.
Okay. Right. So I guess Duncan gets that. So it's not actually recognizing people. It's more like it's doing a Gestalt recognition. Since I use you guys, I'm going to use myself as well, right? But what this shows is that with just a few training examples, which are the numbers indicated here, you can train the system to recognize new categories with a relatively good robustness to variations of various kinds in size, position, etc. So that's sort of the power of deep learning, if you want. And this only became practical only in the last couple of years. It's been widely deployed among other people by Microsoft for speech recognition, as well as by Google, and for image recognition by just about every web company now. So it's taken the world of computer vision by storm, and it's been quite a ride, and there's a lot of interesting things to explore here. So one of the things that happened over the last 3 years is that deep learning pretty much revolutionized speech recognition, at least the acoustic modeling part of speech recognition. Deep learning also revolutionized computer vision. A lot of computer vision papers now are just about on deep learning. Nobody talks about designing features anymore. And it's very likely that the next frontier for deep learning is going to be natural language processing and language modeling. A lot of people are working on this. Some of us are thinking of essentially embedding all entities that we're looking at, images, text, speech, in a common space, actually following an inspiration that was originally proposed by Léon Bottou. And I think there's a lot of very promising avenues there. So here you go for a completely contentless 5-minute technical talk. And I thank you very much for your attention.
All right, so I'll use my 5 minutes to talk a little bit about myself and my research, touch on the things that we do at Cornell Tech, and talk a little bit about the challenges that I see for us in New York in data science. So it's going to take 5 minutes, I promise you. If it takes, okay. All right, 6 minutes, none. If anything more, just shoot me. I call myself an information scientist. My background, my PhD is in computer science. I do a lot of data work, in particular around social media. My research in the last few years looked at social media data, and we did social media data science from the first days of social media and from slightly before there was data science.
So the methods that I use range from those that require deep engagement with individual users. So we do ethnographies, we do interviews sometimes, social science style, to methods that require shallow connections with lots of Amazon servers, when we have computational methods at scale. Hence, I call this information science. In particular, this year and the last few years, we've been interested in social media applications for cities, for urban areas. Social media is public, mostly available in a semi-proprietary manner, a lot of times location aware, and offers a lot of information for us to process and help us understand cities. So what can we do? Here are just a couple of examples, very briefly. Especially in New York, there is a constant stream, real-time flow of social media information about the city. So we built this system called CityBeat that is kind of a dashboard for journalists and city staff to understand in real time what is happening in New York. This system called ParksBeat, which we just started working on, is working with the New York City Department of Parks and Recreation to use the social media shared in New York parks to help them improve their operations. And I'll briefly mention my startup, which we have related data analysis work to make sense of the world stories based on the social media that's shared from them. We want to make those stories accessible and not just huge amounts of content that are slapped on a page. And those systems that I talked about are rooted in user-centered design and computational methods like NLP and machine learning, and in HCI, in human-computer interaction. But other than the systems work, I also do work that is more theoretical in nature, perhaps in an area that's sometimes called or overlap with computational social science. So in one study, we have, as you know, from the media, everyone is asking whether social media is making us lonely. This is not interesting. Our interesting question is, we know that people are using social media to tell us about, to communicate their emotional experiences. What can we learn from their communication about the experience of loneliness and about how that experience plays out and relates to social media? So doing this kind of work obviously requires knowledge from a lot of different disciplines, including sociology, psychology, communication, and many others. So those of you who know me know that I'm not the expert in any of them. So that's our first challenge that becomes, how do we acquire those expertise around those disciplines that we want to work on? So one thing that we're doing at Cornell Tech, we have the Jacobs Institute, which is a Cornell Technion collaboration. The activity in the Jacobs Institute is organized around hubs. And the hubs are, we don't have a data science program. We have programs that are centered around hubs where we also teach data science. So hubs right now are connected media, healthier life, and built environments. And we want to make sure that those hubs provide, help us bring people from different disciplines to reason about these areas. So the main challenge that we have, I argue, is not data, is the people. And the people-related challenges for data science are numerous. First, the ethics of data science. We all came up with those questions, not what we can do, but what we should do. The second is data measurement. How do we reason about the data that's available versus the data that we need to solve the problems that we want to address? Modeling, which we already started tackling, but have shown us how something like Google Flu Trends turned from the poster child of data science to the Titanic of big data very quickly. That was all about modeling. Obviously, we have the challenge of interpretation. And particularly, we have the challenge of mission. We have Jeff Hammerbacher that famously said that the greatest minds of our generation are getting people to click on ads. We need to make sure that this doesn't happen to us here in New York. So we need to use data to solve the problems that matter. And that, I think, will be our greatest challenge. And that's particularly why I'm excited to do this, to have you all here in this room and to do this in New York. Because we can do it. We're not in the Valley. We're embedded in a non-techie culture. We have many different disciplines represented even in this room. And together, we can focus on the application of the ideas that matter and make them move forward. I think we also have the advantage of being one short subway ride away from each other. So let's get data science right. Thank you.
I was told to keep my talk as short as possible. I'll be talking about learning from large-scale mobile phone data sets. So I'll be focusing on the data rather than the algorithms. And I'm at Columbia University, and we have an interesting new initiative that started in 2012 called the Institute for Data Sciences and Engineering. We are, let's say, required by NYC EDC to hire many faculty, and these faculty will populate 6 different centers looking at data science for health, smart cities, finance, security, new media, and foundations of data science. So please come talk to Kathy, the director, and myself after the talk about this institute. I'll be focusing on some data that I'm very excited about, large-scale mobile phone data. I started a company in 2006 called Sense Networks, which was looking at app data and call detail records from large phone companies to see how people move around the city and how they use their phones to communicate, and trying to model that for some interesting social and entrepreneurial applications. One application is basically looking at how people flow in a city. If you build a Markov model of how people go from one place to another, you can embed the resulting directed graph and then start color coding places that attract similar people. And so if you go here, you might also want to go there, and we can do these types of recommendations just by looking at flow. You can also do things that are more specific on each user. You can try to model each individual's user and their behavior history by looking at the types of places they visit. For every week hour, we look at what types of activities are you doing. Are you in cafes or restaurants? And we build these matrices that describe each user. And then we can say how similar is one user to another just by computing the Euclidean distance between any of these two matrices that summarize them. So if they are spending their Thursday afternoons in cafes, they might line up very similarly. And so we did this, and then we connected the networks. We connected the data into a network by minimizing these Euclidean distances, and we were able to form little Facebook-like networks from people's mobile phone data by saying, oh, you overlapped a lot with this other person, so you should be connected to them in our model. We can do things like label you then if we have this type of network and say, okay, here are the people that were parents in our data. Can we propagate their labels to other people and predict that they're going to be parents even if they didn't reveal that about themselves? So we started labeling and doing kind of the machine learning approach of diffusing labels on this graph. And that basically is called semi-supervised learning. And it performed pretty well. From just a few thousand labeled people, we were able to do things like predict if people were parents. We were able to do gender prediction, if they were single or not, if they were students or not, by looking at these networks we formed. And it's much better than random. Obviously not perfect, but we were able to get some interesting labels by building these graphs. But then we were recently curious about why did we use Euclidean distance, and saying if you co-locate with someone, then you're going to be connected to them. Clearly, if you co-locate with me at home, then you're much more likely to be like me. But if you co-locate with me in a subway station, that shouldn't count as much. So we shouldn't just look at total co-location. We should see which places matter more, which places matter less. And so this led us to look at this problem called the freshman problem, which is if you only know features about people, can you predict how they were going to connect, let's say, after their first year at school? So this is why they're called freshmen. And we have X, which is features about a bunch of people. And then at the end of the year, we see a matrix of who connected to whom. Can we learn how to predict A from X? And the way we decided to do that was we decided to see which attributes matter more than others. So let's say we have some friends here. This is their matrix of connectivity A. And here are some height and weight attributes. We'd like to predict on these new people, how are they going to be friends, by saying, well, does height matter more than weight? Can we compute distances more, let's say, for one feature than another to get a better network at the end? And so we looked at various applications like Facebook. Can I predict who's going to be friends by figuring out which features in your user profile matter more? We also looked at Wikipedia datasets, Foursquare datasets, and telco datasets. And I'll give a couple of quick examples since I'm running low on time. But the idea is not to just connect people by Euclidean distance, but to learn a matrix M, which figures out which distances matter more than others. This is called the Mahalanobis distance. And so here's an optimization we solve, which basically says if you are connected to someone, then I want to change distances so that you're closer in some other space to them. And so I'm pulling and pushing distances to make people that are friends closer. and people that aren't friends further apart. We solve this using stochastic subgradient descent. And we get some interesting lift curves. For example, over here we get the ROC curve outperforming other techniques at reconstructing the Wikipedia hyperlink structure from the Wikipedia word counts. And so we've seen some nice improvements on Wikipedia network reconstruction, on Facebook network reconstruction, and on Foursquare. And just a quick example, on Foursquare data sets, we looked at 4 different schools, and it turns out, for example, at Columbia, it matters what year you're in for your friendship connectivity. At MIT, it really matters what dorm you're in for your friendship connectivity. That's the attribute that matters more. At Harvard, your status matters more for determining your friendships. And then on the mobile phone data, what we did was we said which locations matter more for making people call each other and connect through phone calls. And so over here is just the locations in a city by how frequently they're visited. And over here, we see which distances matter in co-location land. And so it turns out if you co-locate over here, you're more likely to call someone than if you co-located, let's say, in the darker areas. And so now we're able to predict phone call patterns from co-location patterns. This is preliminary results. But again, the key idea is to look at mobile and social data and to see how behaviors and attributes help predict social link formation, and then how social links help us predict attributes, behavior, and behavior contagion as well. Thank you.
So thank all of you for being here. Oh, we have all men speakers. I didn't even realize that until right now, but thank goodness a woman is running the show. So okay, well, thank you so much for being here. I'm really thrilled that we're bringing all of these great places together. We've called this the Data Science Seminar, and I think big data was a terrible phrase, and I think data science is now becoming too much of a buzzword as well. So more is calling it information science. But I was wondering for each of you, how do you define the boundaries of data science? Or if that's too hard a task, can you give me one example of a data science project or problem that would not have been possible, let's say 5 years ago, that you think is going to be transformative over the next 5 years, 5 to 10 years? Tony.
Okay, I'll go first. I like Chris Wiggins' interpretation of data science. He has a really great Venn diagram picture, which says that it's an intersection of computation, statistics, and actually domain expertise. And, oh, so you stole it from someone. Okay. Drew Conway. So I didn't follow the links. But I think that's a good interpretation. I think that's a little different from what, let's say, machine learning, let's say, embodies, which is the intersection of computation and statistics. Data science is really also working with a lot of domain experts to really figure out what the important problems are and to also understand their data sets more closely rather than just, faster algorithms and better generalization guarantees. So, I like that picture, and I'll make sure to say Drew Conway next time. Sorry.
So.
You can go ahead.
Yeah, so I don't have a definition for data science other than say, the shortest perhaps description is anything that has to do with the extraction of knowledge from data, perhaps with the help of machines or math. I would call data science, and particularly if it has applications to the sciences, society, business, health, etc. I like the term data science compared to, say, machine learning or statistics, or even computational statistics, in the sense that it's very inclusive. If you say machine learning, the statisticians feel left out, and the people who doing application feel left out. If you say statistics, the computer scientists say, well, what about computation? And but if you say data science is kind of a neutral ground and it's sort of more inclusive, I wouldn't call it the intersection of any of those fields, more the union. Of course, there are boundaries somewhere, but to some extent, data science is really finding the boundaries between computer science, statistics, and application areas.
I knew you were going to ask that, so I just asked the internet, and that's what the internet said. So I think there's work to be done on the definition.
There sure is. This is just, yeah, it's awful, actually. It's awful.
Yeah,
wow, we all have a lot of education to do. Chris wants to say something.
That's
so
right. I'm pretty
so
sure.
For the tape. Right. So
we need to do
Chris
some
wants
data science
to do
around
a
that.
controlled experiment. Physics is, and right.
Right. I was gonna say I'm pretty sure. I'm pretty sure physics is not like teenage sex, but any other way.
Doesn't say sex, actually.
That just. But so I think we have a little of a red herring in the science, which brings back, obviously, all of us heard this computer science is science, and why is this a science? And I think the same question has to be told for data science. It's a catchy name. We don't know if it's a science or not, in the sense that we're not testing and validating hypotheses and so forth. But it is not always, right? We also do that. But it does, to me, just tell the story of how data became both prevalent and important, and requires us to come up with a new set of tools to understand and reason about it.
Okay. So on the flip side, which Moore actually also brought up in his talk, we all know that there are ethical questions. There are all kinds of questions around privacy. On our panel here, I think we have people who more focus on the benefits of data science than on the costs or possible costs of data science. But I wonder how you view your role as data scientists and how much you feel that part of that role is defining the ethical boundaries, both in a philosophical sense and in a technical sense too. How do you try to technically address some of those issues?
Taking a risk here. So data science, of course, is very dangerous in many ways because there is all kinds of issues about privacy invasion and data flying around on all kinds of people by companies that they have no relationship with. So there's a lot of people who use services like Microsoft, Google, and Facebook, where the company you interact with has a face and has a relationship with you, provides you with a way of controlling the information they have on you. But there's a lot of companies as well that actually collect your data without you knowing it. And I'm sorry to say that includes yours, but but not just yours. I mean, this includes lots and lots of companies that show you ads and stuff like that with whom you have essentially no relationship, and that's certainly a major problem that needs to be addressed. There's a second issue, which is that data science is on a collision course with AI. So people forgot about AI for a few decades, and now AI is coming back because people are kind of have the idea that the progress of computer technology and the availability of data makes AI a kind of a kosher subject to work on again, and AI will be used for data science. There's no question. And people are scared about AI as well. So if you merge those two things and you start talking to people, we have tons of data about you, and we're going to apply AI systems on this. It's kind of scary, and we have to sort of figure out how to do this properly without abuse.
So I think there are a few things we can do. One is to engage with lawmakers and policymakers because we understand what can be done and they don't understand what can be done. So that's something that we need to do. The second is to engage with critical thinkers, and I know you guys are actually doing it well in Cambridge and here. Microsoft Research, I don't know if Microsoft as a whole does the same thing. But it's easy for us to do it, especially in New York, so that's great news. The third is to consider and highlight those issues in our work. So the two systems that I showed you, or that I showed screenshot of, CityBit and ParksBit, both have significant bias issues. Because in CityBit, you'll see mostly Manhattan is represented and all the other boroughs, because they don't produce social media data, they disappear. ParksBit, the same thing. It'd be very easy to create a system that sends all the park maintenance people to Central Park and Morningside Park and maybe Washington Square, and nobody will ever show up in the Bronx. So we need to think about and highlight those issues and technologies that we create as well.
I agree. I think we also need to, as data scientists, work with people that are on the privacy and on the legal side of things. So I've been collaborating with lawyers in Maryland. We published an article at the NYU Law Review on the privacy issues behind location data. I think it's only by continuing to do this science and working with other researchers and publishing all the results that, eventually things will change. If we don't actually spearhead these efforts, they're going to be done internally in places that aren't interested in publication, that aren't research centers, and that aren't collaborative. So I think we need to keep things going rather than slow things down, because that's what prevents, I think, people who aren't planning on doing this in the name of science from moving ahead of us.
Tony, you brought in the lawyers. Now we're all doomed.
No, I don't think we're doomed. Actually, I really think that we should be engaging more with the lawyers. I mean, they are the lawyers, the legislators. They are going to write the laws, and so we had better be working with them and making sure that they are as well informed as they can be. They also like to cite research, they like to cite precedents, and unless we produce that research and those precedents, they're going to pull anecdotes out of the air and legislate by anecdote instead of by science and research. So and so the lawyers with whom you work didn't mind your collecting all this phone data?
So we don't collect the data, it's running behind the firewall at the telco, so it's never exiting. Okay. We give them the algorithms, they run the data.
I see. Okay. So this was also mentioned. It was mentioned by Duncan and by Moore and others. So what do you think that we can do in New York to make data science different from the Valley, different from what might happen otherwise? How can we take the engagement of a vibrant city with this data science being done by people who are inhabitants of a place that looks like much of the future of the world will look, to make data science better than it would otherwise have been?
Dan Huttenlocker, our dean, likes to say that New York is great because for every topic X, there are enough. There's a critical mass of people that care about X, and I think that's in New York, right? And that's true for academia as well. And I think that's why, especially since I don't think anywhere else in the world right now we're going to have such concentration of people interested in this topic in a very strong academic environment that has so many other fields. Not to mention our other industries, the fashion industry, the finance industry, the media industry, they're all here. So I think that's where we have an advantage. We are sitting with, we're co-located with, not only we sit in this community by ourselves with the techies, but we also co-located with other significant industries that have interesting questions and have interesting ideas. And Facebook.
So,
and
okay, it's 20 bucks.
Microsoft did not say that. You heard where that came from.
So I don't think we should define data science in New York or in this area by by contrast with what goes on in the valley. It's different by nature, but because of the high concentration of people, because of I sensed a little bit more openness. So there's a lot of things that goes on in the valley that you never hear about because it's done in small startups that may or may not succeed, that don't want to talk too much about what they do. Whereas here, there's a bit more of a kind of a infrastructure tissue substrate of sort of academic research, including at places like Microsoft and soon Facebook and NYU, Columbia, Cornell, and that creates enough communication forums like this one where people exchange ideas, which I don't think goes on in the valley nearly as much. So that's one big difference. It's nice to see also that there is a pretty vibrant scene of startup companies, within 10 blocks of here, mostly south of here, but also west, and the diversity of companies that have activities in the area, I think, contributes to this, particularly media and pharma and things like that. So, I think Chris and I were on a panel recently talking about what's happening in New York in data science, and I think there is it's very fertile ground, and it's been growing in the last 2 years at amazing speed. Who would have thought 2 years ago, would have imagined the kind of state that we are in now, data science in New York, all the things that are happening. This is going to attract a lot of top-level people working in our fields who are going to want to work in New York just because of all the buzz that's happening here.
Tony, do you?
I mean, I totally agree. I think New York is a very interdisciplinary place, and that's a very important thing. If you're doing data science, you want to work with as many different types of data as possible. So I'm excited that I can see data from finance, from health, from new media, from social networks, and the whole kind of variety of it. And also New York City itself has a great initiative, partly from the previous mayor, but also from this mayor, to open up a lot of the New York City, urban data out to researchers. So we actually got from the Taxi and Limousine Commission lots of data about GPS locations of taxis, and that's, I think, you need a visionary kind of city and a visionary mayor to make that happen, and I think New York has been spearheading that and really helping create these data sets for people to work with and to model New York as a data science problem.
Great. Well, thank you. I actually think that the main purpose of these evenings is for us to be able to talk to each other, to get together. As Jan was saying, this may be more than anything else what separates us from the valley, that we can all just walk over or hop on a subway and be in the same place at the same time. So I really want to thank the three of you, and I want to thank everybody who did walk or hop on a subway and come here, and we have some food for you, and please enjoy the food and enjoy each other. Thank you.